In 3.1, we went over the vocabulary for polynomials, and we also quickly talked about how to add and subtract polynomial functions. This was really simple. Essentially, what you had to do was if you were adding, you kept the signs. If you were subtracting, you would distribute the negative to the terms in the second set of parentheses, and then you'd combine like terms. Now we're going to be taking a look at multiplying polynomials. And there's two very important issues you will face when you're multiplying polynomials. The first thing is when you're multiplying, you must add the exponents. A property of exponents looks like this. If I have x to some power times x to some other power, as long as we have the same base, so both of them are the same variable, then we can add the exponents, so m plus n. And the second thing is combining like terms at the end means that exponents stay the same. So we add the exponents when we multiply. However, when we add exponents, they stay the same. So add, I'll just put adding or subtracting. It stays the same. Just like what we saw in the 3.1 video. Example 1, we have a monomial times a polynomial. That basically means we have one term times multiple terms. When we have something like this, I recommend using arrows. We essentially have been doing this for a while. Think about when we distribute a number to stuff inside of parentheses. When we FOIL, we use arrows. So what I'm going to do is I'm going to use arrows to show that this negative 2x to the fourth power is going to be multiplied by every single term that's inside of these parentheses, okay? So the first thing that I have is negative 2x to the fourth times a positive 3x to the fifth. I like to do my numbers first, so negative 2 times 3 is a negative 6. And then x to the fourth power times x to the fifth power. Since we're multiplying them together, we add the exponents. So 4 plus 5 is 9, so x to the ninth power. Okay, next I have negative 2x to the fourth power times 7x cubed. Let's do our constants first. Negative 2 times positive 7 is a negative 14. X to the fourth times x cubed, we would add the exponents. So 4 plus 3 is 7. So x to the seventh power. Now we have negative 2x to the fourth times a negative 11x. Let's do the constants first once again. Negative 2 times a negative 11 is a positive 22. And then we have x to the fourth power times x. This is understood to be x to the first power. So 4 plus 1 is 5. X to the fifth power. All right, last one, negative 2 times x to the fourth power times a negative 4. Negative 2 times a negative 4 is a positive 8. Now there was no x here, so we would just keep the x to the fourth power. Example 2, we now see a binomial times a binomial. If we were using the table from our notes from yesterday, something that has two terms is a binomial. So we have two terms times two terms. What you'd want to do here is just FOIL. We've been doing this all along. It's not really anything new. So it's first negative 5x times 2x. Let's do the constants first. Negative 5 times 2 is a negative 10. X times x is x squared because we would add the 1 and the 1. Outside, so negative 5x times a negative 9 would give me a positive 45x. Inside term, so positive 3 times a positive 2x is a positive 6x. And then the last terms are just numbers, so positive 3 times negative 9 is a negative 27. If we can combine like terms, we would like to. I do see two terms that have x in it. So I would just want to combine these real quick to give me a negative 10x squared plus 51x minus 27. There is another method you can use. I don't like it so much when it's just binomials. I prefer it when we get a lot more information, so bigger polynomials, but I'll show it to you now. It's essentially box method in reverse. Remember I taught factoring using box method. It's just now instead of filling out the inside squares first and finding the outside, we're going to put the stuff we already know on the outside and fill in the inside. My first set of parentheses is negative 5x plus 3. So I'm going to put a negative 5x and then a positive 3 here. And then my second binomial is 2x minus 9. So I'm going to go back here and do 2x minus 9. All right, to fill in the boxes, we would have to multiply the term above and to the left. So in this box, we have 2x and negative 5x. If I multiply those together, 2 times negative 5 is negative 10. X times x is x squared. In the second box, I have negative 9 on top, and once again, negative 5x on the left-hand side. Multiply those together, I get a positive 45x. And then now I have a 2x here and a positive 3 here. So 2x times 3 is a 6x. And then this last box, negative 9 is above, positive 3 is to the left, so that would give me a negative 27. Now something that makes it easier, and you'll see that later when we have a more complex one, is we combine the diagonals. So I can see my like terms by taking a look at the diagonals. It doesn't always work, but most of the time it does work. So now I can write my final answer, negative 10x squared. Combine my diagonals because it's x and x, which gives me plus 51x, and then minus 27. You'll notice how we ended up with the same answer for both of them. I just used different methods. All right, the next one we have 9x minus 4 being squared. I want to remind you that when we square, you do not distribute the power of 2. Okay? You do not distribute this power. It doesn't work like that. When we have something squared, it's technically something times itself. So I have 9x minus 4 times 9x minus 4. In this case, I have two binomials, so I would just use the arrow method. It's not that difficult for us to just keep track of our arrows and FOIL it out. So 9x times 9x is 81x squared. 9x times a negative 4 is a negative 36x. Negative 4 times a positive 9x is a negative 36x. And then negative 4 times negative 4 is a positive 16. Careful with your signs. Sign mistakes usually are what gets people. And now I just have to combine like terms. So 81x squared, combine my x terms, gives me a negative 72x plus 16. I think that using arrows is good when we are multiplying with monomials on the outside, just like what we saw in example 1. And then it's also good when we're using binomials, like what we saw in both parts of example 2. I like box method for something like this, okay? This is example 3. We have a trinomial, because 1, 2, 3 terms, and then 1, 2, 3, 4, 5. So we have a polynomial with 5 terms. It's a lot more work, right? And if I were to try to do arrows, this would have an arrow to every single one of those 5 terms. The 2x would have an arrow to every single one of the 5 terms. The negative 4 would have arrows to all of the 5 terms. It's too much. So instead, let's use the box method. On the outside, I'm going to put my negative x squared to x minus 4, and then I'm going to put my 5-term polynomial up here, 6x to the 4th negative x cubed, 7x squared, minus 8x, and then a positive 5. Once again, when we're doing box method, we're kind of doing the opposite. So now I'm filling in the boxes by looking what's on top and to the left. So I'm going to start here. I have a 6x to the 4th times a negative x squared. We'll do the numbers first. 6 times negative 1 is a negative 6. And then I have x squared times x to the 4th. Remember, when we multiply, we add the exponents. So this is really x to the 2 plus 4 power or to the 6 power. I'm just going to work down this way, actually. So now I have 6x to the 4th times 2x. Doing the numbers first, I have 6 times 2, which is 12, and x to the 4th times x. So this is technically x to the 1st power, making this an x to a 5th power when we multiply. And last one in this column here, we have 6 times negative 4, that's a negative 24, and I have that x to the 4th power. There's no x for it to combine here, so it just stays the same power. Okay, moving on, I have negative x cubed here on top, and now I'm just going to multiply by each thing that's on the left. So negative x cubed times a negative x squared. 2 negatives makes a positive, and I have x cubed and x squared. If I add that, that's x to the 5th power. Now I have a negative times 2, so negative 2. X cubed times x to the 1st becomes x to the 4th. I just added 1 plus 3. And then the last one, negative 1 times negative 4 is a positive 4. And I'm going to keep that x cubed because there's no x to combine it with here. Now we have 7x squared. Same thing. I'm going to multiply it by each thing that's to the left. 7 times a negative 1 is a negative 7. X squared times x squared is x to the 2 plus 2, so 4th power. 7 times 2 is 14. X to the 1st times x squared is x cubed, because it's 1 plus 2. And then the last one, 7x squared times negative 4, would give me a negative 28. I'm going to keep that x squared. All right, now we have the negative 8x. So I would multiply it by everything that's on the left. Once again, negative 8 times a negative 1 is a positive 8. X times x squared is x cubed. Technically, this is a 1, so 2 plus 1. Next, we have negative 8x times 2x. So negative 8 times 2 is a negative 16. X is x squared because it's 1 plus 1. Negative 8x times negative 4 is a positive 32x. And then 5, I can do this one really quickly. 5 times negative x squared is a negative 5x squared. 5 times 2 is 10, so I have 10x. 5 times negative 4 is negative 20. Wow, that was a lot of work. But the reason why the box method is so much better for this type of problem is because now when I need to combine like terms, I can use the diagonals. Notice how all of these are x to the 5th, x to the 4th, x cubed, x squared, and then x. Then I have my highest power and then my constant on the ends. So when I write it, I'll just put little circles there too. So when I write it, I will put the highest power term first, so negative 6x to the 6th power. And I want to go from highest to lowest power. This is standard form. I'm going to combine this by just adding. 12 plus 1 is a 13, so 13x to the 5th. Then I have a negative 24 minus 2 minus 7. That would be negative 33x to the 4th. Then I have 4 plus 14 plus 8. That would give me 26x cubed. Okay, now looking at the x squares, I have negative 28, negative 16, negative 5. So add all those together, I would get a negative 49x squared. And then 32x plus 10x, that should be easy, it's 42x, and then minus 20. Whew. So we have officially multiplied that trinomial by that polynomial with 5 terms. Again, you can kind of see how this would be a lot easier than having arrows flying all over. Watch part 2 for example 4, and then try problems.